Welcome. Today we're going to work on simplifying rational expressions. In other words, fractions. Now, these fractions aren't going to be your basic fraction. These are going to be polynomial fractions. So the first step you're going to want to do in each of these is to factor the numerator completely. The next step is to factor the denominator completely, when possible. And then finally, you're going to reduce what's left. Now, the first example I have for you is already factored for you. And when I look at these, I can say, oh, hey, wait a minute, 2x plus 5. Something on top tries to reduce with something on bottom. 5 plus 2x. Those don't look the same. But would you agree with me that the order of addition doesn't matter and that we're allowed to switch it around without incident? So in other words, I could rewrite this as 2x plus 5 without any harm or foul. All right, so these are equivalent expressions. There's no difference between them in terms of value-wise. So I can reduce these two, or these two, if you would prefer to do it. I can reduce these because it goes into itself once. Now let me just erase this so it's out of the way. So those become ones. When they reduce, they don't just disappear, they become the number 1. Now remember, the number 1 times anything is that thing. Now, can I do that with subtraction? Am I allowed to just reorder subtraction? The answer is no, I cannot. However, if I take, let's say, if I wanted 4 minus x to become x minus 4, well, there is a process in math that we're allowed to do, and I'll show you how this works. First, I could factor out a negative 1 from this. If I did factor that out, that would become a negative 4 and a positive x. Instead of a negative, it would become a positive. Well, technically, let's leave it and let's write it as minus a negative x. I know we could have gone positive directly, but there's a method behind my madness, trust me. So the next thing, we know subtracting a negative is adding a positive. And now I can go to, when I have this, I can rewrite it. I can change the order of addition to x plus negative 4. And finally, I can say that x plus a negative is the same as subtracting a positive. Now, will you have to do that step, by step procedure? No. What we're going to do instead is we're going to say, oh, now that I know that that is true, I've kind of proved it to myself, then I can say if I pull out a negative 1, it changes the order of the subtraction. So I'm going to pull out a negative 1 and this becomes x minus 4 instead of 4 minus x. Now I can reduce the x minus 4 on bottom with the x minus 4 on the top of the fraction. On top, I only have 1s. On bottom, I have a negative 1 times 1, so that's negative 1. The answer is negative 1. And that's my final answer when reducing. Most of them don't require that, but occasionally you see that. Now, what do I do with something like this? Well, I've got a fraction with single terms only. There's no addition, no subtraction. In that situation, I can reduce the 21 and the 14, for example. 7 goes into both. 7 goes into this 3 and this 2. I can reduce the variables to a power. Remember, when reducing a variable to a power, you subtract exponents. So this becomes the number 1, and this becomes x to the 4th. The bigger number stays where it is. So the top is going to have x to the 4th, the bottom, the x's cancel. If this had been reversed, in other words, a reciprocal of that, then the x to the 4 would be on bottom. I simplify by saying 3x to the 4th over 2 is my answer, and I'm all done with that problem. Now, here are a couple examples. We'll focus on one at a time. So, in this problem, I've got a trinomial on top, a trinomial on bottom. Remember, factor completely, you always look for a GCF, but in these two cases, there's no GCF. So I'm just going to basic factor the top. X, signs are minus and plus, that means one plus and one minus. And I need a pair of numbers that multiply to 12. And because these are different, they differ by 1, because that's understood to be a 1. Technically, it's a negative 1. 4 and 3 multiply to 12 and differ by 1. So I want the 3 to be positive and the 4 to be negative. That's going to give me my negative 1. Down here, x and x, signs minus plus gives me a minus and a minus here. Multiplies to 12 and differs and adds, to 7, 3, and 4. All right. I know many of you are saying, screaming into the screen, going, why didn't you just cancel out the x squareds and cancel out the 12s? Well, there's a very good reason for that. You can't reduce something that's added or subtracted with something else. For example, let me just do this example and then I'll get back to this. So let me move this up so it's out of the way a little bit. If I had x plus 10 over x, you'd want to cross out the x's. But what if I told you that that was, no, that's not what I wanted. I wanted x plus 1 over x. What if I then said x was 10? Well, normally, if you were working with this, that would be 11 over 10 or 1 and 1/10. But if you thought you could cross off the 10s, that would equal 2. 2 doesn't equal 1 and 1/10. We know this is right. That's not right. Those aren't equal. You're not allowed to reduce something that's part of an addition or subtraction with something else. Now, earlier, we reduced entire additions or subtractions, but those were multiplied times other things. Multiplication, yes. Additions, individual addition, subtraction, no. So let's get back to our problem here. Get rid of that so it's out of our way, and we can actually get to reducing. The x, they have to be identical in the parenthesis to reduce. The x minus 4 and the x minus 4 can reduce. X plus 3, x minus 3. Are those identical? No. So x plus 3 over x minus 3, that is your answer. Let's take a look at this one. GCF on top. GCF on top, let's see, 6x squared. I'm going to factor out a 6x squared, and I get x minus 5, the x squared's gone. Okay. On the bottom, I'm going to factor out 3x. That leaves me x squared plus x minus 30. Now that's just factoring out the GCF. The next step is what's in the parentheses. Can I factor further? 6x squared, x minus 5. No reducing, factoring here. 3x. Let's see if this will factor into two parentheses. X and x. Sign a plus and a minus gives us 1 plus and 1 minus. Let's see, 6 times 5 is 30 and differs by 1, different signs. So I want my 6 and my 5. Now, a hint, if it's going to reduce, the 5 is going to have to go here, right? So that kind of gives you a hint as to how to factor it. Now, let's see if that works if I put the 6 here. A positive 6 and a negative 5 do give me a positive 1, negative 30, and x squared. So it did work. So now I'm going to reduce. I can reduce the x minus 5 with the x minus 5. I can also reduce, now when I do single terms like this, because they're multiplied times the parenthesis, I am allowed to reduce them. The 6, I use the coefficients first, the 6 and the 3, 1 and 2, because 3 goes into both. The x and the x squared, this becomes x, this becomes a 1. And so what am I left with here? I need to move this up a little bit. No, not like that. When I'm all done here, on top I'm left with a 2 and an x times 1 is 2x rather. And on bottom all I'm left with is x plus 6. Now I'm all done. All right. This one, when you look at it, you say, hey, wait a minute. I don't want my x squared term down here and I don't want it negative. I'm going to rewrite that x squared, this expression. I am just going to rewrite it. Negative x squared plus 5, sorry, not x, it's a y. Let me fix that. Negative y squared plus 5y plus 14. Easy to forget that you're not using x's anymore. Now, I don't like my first term to be negative because my sign chart doesn't work if my first term is negative. So I'm going to factor out a negative 1. That changes all the signs inside to y squared minus 5y minus 14. Now I'm going to go ahead and do some of my factoring. On top, I'm going to factor into two parentheses, y and y, a plus and a minus. 6 and 7 differ by 1, 6, 7. On the bottom, negative 1. Again, y and y, but this time plus and minus. Multiplies to 14, differs by 5, 7 and 2. Now likely the 7's going to be here and the 2's here. That's going to give me a negative 5. It sure worked. Now I can go ahead and try to reduce. The y minus 7's cancel. That leaves me with y plus 6 over negative 1, y plus 2. By the way, something I didn't mention before this, when you get to your final answer, don't distribute it back in. Leave it factored out. Leave your final answer like this. Don't distribute the negative 1 in. It just means more work for both of us. All right, now you're looking at this one and you desperately want to reduce those 27s, but remember, you can't reduce something that's part of an addition or subtraction individually. So what I have to do here is I have to factor properly. On top, 4 terms. That gives you a big hint. Group factoring. There's no GCF. So I'm going to do this kind of group and that kind of group. I'm going to pull out an x squared here. That leaves me with 2x plus 3. Over here, I'm going to pull a positive 9. That leaves me with 2x plus 3. And what that leads to is they both have a 2x plus 3. 2x plus 3. They're identical. I factor it out. What's left in the other parenthesis is x squared plus 9. This is all review. This is not new to you. Over here, I can pull out Oh, nothing. So I have to factor it into 2 parentheses. Now, I may want to do that factoring and just rewrite it over there. Remember here, x and x, I got to leave a little room. Plus and plus. I need a pair of numbers to give me 2. I also need a pair of numbers to give me 27. Now, if I look at that, that's a huge hint. I am likely to put 2 and 1 and then have the 3 with the 2. Now, what times 3 gives you 27? 9. Did that work? Now, I know this gives me 27 and this gives me 2x squared, but did it give me my middle term? 3x, 18x. Does that add up to 21x? Sure it does. So now I know when I rewrite over here, 2x plus 3 and x plus 9. All right, we've got what we wanted. Now I'm going to reduce the 2x plus 3's, and I want to, but I can't reduce these. This is x squared, that's not. So I have x squared plus 9 and x plus 9. That's my answer. Is this my last one? Yes, my last problem. All right. So in this one, I'm going to factor out, if I can, a GCF on top and on bottom. The top I can pull out a 2, and the bottom looks like I can pull out a 4. Let's see what happens when we factor out a 2 on top. A squared minus 49. On bottom, a squared plus, let's see, 4 goes into 5 once, carry it, 4. So 14a, and likely 49, 49. Now I need to factor these in purple into 2 parentheses, if I can. Well, difference of 2 squares, a plus 7, a minus 7. This, a plus, likely it's going to be a 7 in there, because 7 times 7 is 49, and 7 plus 7 happens to be 14. So there's our factoring. Now I'm going to go ahead and reduce. I can reduce a plus 7 with a plus 7. I can reduce 2 and 4, because they're part of multiplication, not addition. Now, a lot of people are going to want to say, oh, can't I just pull a negative 1 out of this so that it becomes a plus 7? Nope, that would be negative a plus 7, not the same as a plus 7. So you end up with a minus 7 on top, 2 times a plus 7 on the bottom. You're done. Don't go any further. That's it. That's it for today, and you're only going to do the part of the worksheet. Check for Google Classroom to see which problems you will do.